Hey guys, it's Miss Briggs, and these are some of the questions that y'all had been asking me, so I wanted to give an opportunity for you to hear about how we would address some of these questions on our homework. So the first question that was given to me was, a teacher heated two 500 milliliter flasks of water to 50 degrees Celsius. The teacher then removed the flask from the heat and wrapped each flask in a different material. The teacher recorded the temperature of the water in each flask every 5 minutes for 20 minutes. The data are shown in the table. The question is, which conclusion is supported best by the data? The best thing I always find to do is take each answer choice and look at it in comparison with the data. So we need to decide with each one which one is going to work best. So I'm going to get my drawing tool ready. Okay, so the water in flask A is better insulator than the water in flask B. Remember that an insulator stops the flow of energy. So if I'm looking at flask A, it is stopping the flow of energy because less energy has been lost in flask A than in flask B. But we need to go ahead and keep looking. So we're going to star this one. That could be our answer, but we need to evaluate all answer choices. B says the water in flask A has a higher conductivity than the water in flask B. We don't have enough data from our problem to be able to assess that, so I can't fully say that that's true. The material wrapped around flask A is a better insulator than the material wrapped around flask B. Now, I do know that the material is brought up here. That is the difference, that's our variable. Each one's different, okay? So this one is a better answer choice than my first one because the water itself, actually, if I look back at here, the water isn't the insulator, the material is. So at that point, I need to go ahead and cross this out. That's why we always evaluate all answer choices. D says the material wrapped around flask A is a conductor. Remember, a conductor lets the flow of energy go. And the material around flask B is an insulator. Remember that an insulator will stop the flow. Because we see so much change in the energy, it's not really stopping the flow as effectively as with flask A. So that leaves our best answer choice to be C. Number 6 says, yeah, that's right. Which statement describes two ways in which an object might be a conductor? Again, we evaluate all answer choices. The object might dissolve both salt and sugar. I haven't really talked about that, so I'm going to put a question mark right here, but I need to come back and reevaluate. Both heat and electricity move easily through the object. Remember, an insulator stops the flow, a conductor lets it go. So that's true that conductors will allow both heat and electricity to flow through objects. This one sounds the best so far. The object might attract both iron and copper. Well, if I'm worried about attraction, that's going to be something related to magnetism. It's not necessarily going to be something that is always true of a conductor, okay? And then J says both a magnetic field and an electric field surround the object. Again, in our definition for a conductor, it is that it allows heat and electricity to flow through. So J is not our best answer choice. G is, because it aligns with our vocabulary that we've been going over and with our other work we've been doing in class. The next one says a teacher set up the electrical circuit shown below. When the teacher closes the switch, electricity flows through the circuit. The nail attracts the paper clips. Which conclusion is best supported? Again, that doesn't mean other ones might not be totally correct, but I'm looking for the best. The nail becomes a magnet when it conducts electricity. Well, remember, because it's a closed circuit, the energy is allowed to flow through, and when that happens, the paper clips go to the nail. So this is something that could be my answer choice. The paper clips are attracted to electricity. Not necessarily, because they're not going to the battery, they're going to the nail. The battery produces a strong magnetic field. It's not indicating that because, again, it's going to the nail. It's not moving all the way over here to the battery. Can't support that. The paper clips become strong magnets in the presence of electricity. If the paper clips were the magnets, then we would see a different situation. where the nail would go towards the paper clips. That's not what we observe. Therefore, my best answer choice is A. Last one. Students have 2 blocks that are the same size. They drop each block in a beaker of water. Why does block 1 float and block 2 sink? Remember, this is a density question. So block 1 is made of a different material than block 2. Very possible, especially since we know as far as if it's made of the same material, then it doesn't matter the shape it's cut into. It's going to either sink or float based on the particle size. Block 1 is smaller than block 2. Well, we know that's not true because in our problem it says the blocks are the same size. Block 2 absorbs more water than block 1. Remember that the absorption of water doesn't necessarily equate to density. So that one is something that they could use to kind of trick us, but it's not necessarily a direct connection. Block 2 has less mass than block 1. Remember that with the mass, we're talking about the compactness of the particles, and if block 2 has less mass, why does it sink? Question for you, right? Therefore, that one is not a good answer. Our best answer choice is going to be F. Thank you guys so much for watching. If you have any questions, please go ahead and post them here on the thread. Otherwise, I look forward to doing more of these for you guys soon. Have a good night.